Hello students, this is Introduction to Computer Application Part 2. Myself Dr. Prakash Pitroda. I will be taking you through the various data types and how they are used in the program. So in our part 1, what we learned is the meaning of the program, which is sequential set of instructions given to the computer system in order to solve a problem. Then we've also seen the program has basic input or storage of data, the process and the output. Output we have checked with the help of system.out.println program. So what we saw in the previous session, let's very quickly revise. What we saw is that print statement can help you printing the data. We compile the program, which is a process of converting the data and information into the binary system, ones and zeros, and syntax means checking whether the program is grammatically right or not. And then we compile this program, check for no grammatical error. We close this, we take a program, we right click and we make computer follow those instructions, and that's how on a terminal window you will get the output. Now we've also seen that the second type of data that we have is the alphanumeric data. Now alphanumeric data cannot be printed directly. It means it has to be written between a pair of bracket, pair of quotes, double quotes. Alright, so here we have Mumbai, which is written between the pair of double quotes, and India. So my first instruction to the computer is to print Mumbai, second one is to print India. So I compile this program. Again it shows me no grammatical, so called syntax error. I right click and I say void main. So computer prints India and Mumbai in the sequence form what was written. Okay, let's move on further ahead from here. We've also seen last time that in Java, data, when we have to store, the data storage needs to be done using data types. That is, Java has provided various types of data to store various types of you can say raw material, raw data. In that we have seen that two types, basic, numeric and alphanumeric. So today we are going to introduce ourselves with numeric side of a data. So if the data is numeric, that's pure number that can be used for any calculation. If I have to store numeric, the numbers, then I need data types. There are various data types given. So there are, according to Java, there are two different types of number, one being integer, another is decimal. So integer, whole number, decimal is also known as floating point numbers. So to store an integer, you have a special word, the data type we call, they are also known as keywords. We have byte, we have got short, we have got int and we have got long. So here we have got byte, short, int and long. And for floating point number, we have two different types of data. Alright, that's called float and double. So let us explore them in more detail. So we move on to understand how to store data. So storing a data can be done. The syntax, the format that is required, the format that is required is data type, address variable, because computer has a large memory. The data once goes into the memory needs to be stored in a particular place. We call that as an address, which is denoted by a variable. Variable at present we are not going to take more than a word. Later on we'll explore more in detail. Is equal to, so we can say data type address variable is equal to the data value and semicolon, which indicates the end of the program. So assuming that I am storing the byte integer, so I can write byte num, byte is your data type, num is your address, equal to 25 and a semicolon. So I can write byte also, I can write short also, I can write int also, I can write long also. Now if all of them can store 25, then what's the difference that we need to know? So now assuming that 25, which is the decimal number system that we follow, in binary 25 is 1101. Okay, so we know that computer will store everything inside the memory in the form of ones and zeros. So how this will work? So as a programmer, you need to know which one to pick up out of them based on what the value is. So let us understand and explore further. So if it is byte, then as a student we need to know two basic things. Every data type will have a memory size and a data range. A memory size is the amount of memory occupied by a particular data type. So byte has a memory size, and each memory size also stores a particular data value which has a data range, which is minimum to maximum value that a data type can hold, how much I can store. Like for example, in a 1 liter bottle water, you cannot store more than 1 liter. So minimum can be a drop, maximum can be a 1 liter water. So same way here. So when I declare a data, when I write to a computer byte num is equal to 25, so byte indicates to the system the memory size should be reserved is 1 byte, that's 8 bits. So if you look at here the figure, then there are 8 boxes. Okay, and the data range in this minus 2 raised to 7 to plus 2 raised to 7 minus 1, that's minus 128 to plus 127. Any number within the range of this can be stored in byte type. So byte num is equal to 25. This 25 could be anywhere from minus 28 to 127, any number. Beyond which if we try to store, then I will get an error message which we will see in the practical. So when I type this inside the memory, that 25 must have been converted into some binary value and goes, and the remaining bytes which will remain empty, which is unusable. No other part of program can use that. So they are like blocked. Okay, now if it is short, then the memory size will be 2 bytes reservation, that's 16 bits, and data range will be minus 2 to the power 15 to plus 2 to the power 15 minus 1. That's minus 32,768 to plus 32,767. Now here if you can see, if I have taken short, then the same number would still occupy the same space which was there in byte. However, the blocked, now one full byte is blocked, which is a loss of memory. Nobody can use this for any other purpose. So while choosing the data type, based on the value you should choose correctly. So as for integer also, the memory is 4 bytes, that's 32 bits. Data range is minus 2 to the power 31 to plus 2 to the power 31 minus 1. It's nearly a 10 digit number. If I write int num is equal to 25, then this is how the memory will look, where I'm still having 25 being stored. The basic 3 blocks which was lost even during byte type is still there, but it has also further 3 more byte is a pure loss, which is a very big loss in a memory. So as with the long also, if I say long, then it is 8 bytes memory, that's 64 bits. So when you use a keyword, you should know how many bytes and bits are being used. So the data range here is minus 2 to the power 63 to plus 2 to the power 63 minus 1. That's nearly 20 digit number. Now long, if I say num is equal to 25, then you can see I'm still using that 25 as 11001. 3 blocks are still reserved, but if you see 1 2 3 4 5 6 and 7 bytes is a pure loss. It's like you carry a 1 liter bottle with probably a 2 to 3 sips of water, and remaining bottle is a loss because you really can't use that for any other purpose. Now very important for us to understand is, if I really want the long to occupy that actually 8 bits of memory, then the number 25 should end with suffix L, which is very important. If I do not write L, then it will not take memory, the data range beyond the int size. So let us see in a practical. We will move to the practical. So if I take you to the practical, we start understanding from here. So we have seen previously also, I can take a calculation, 2 plus 5, 2 into 5, 10 divided by 2, 5 minus 2, and I multiply. So these instructions I just executed in the order in which they have been written. So this is how the output will look. Now let us explore each type of data. So assuming here that I have taken byte num is equal to 25. So now variable num contains 25 in the memory. So whenever I want to use 25, I should use num, the address which will help computer to go to the memory at place and pick up that value and apply here. So when I say system.out.println num, the computer pointer will go to the memory, look for where is num, in which there must be 25 being stored, which will get printed. So now if I say compile and run, then I will get that 25 being printed on the screen. Now let us understand here, if this number would have been as what we've understood, minus 128 to plus 127. So if I say 127, it still works, shows me no syntax error, it means the number is still applicable. But the moment if I make 128 and I say compile, I immediately get an error message, possible lossy conversion from into byte. So computer is trying to tell you that data type is incompatible. It means the data value is greater than the data type. So you have two choice, either you reduce this number below 128 or you increase the data size, the type. So in this case, of course, we are going to write again 127 and my data is acceptable. If I compile and run, I will still get 127 being printed. Now let us move on to the next one. Same thing will short. I've stored it and I've applied it. What if I say num into num? Then computer will apply 25 and 25 in both these cases, and 25 into 25, 625 should get printed. So I compile this, I run, and this is how I get to 625. However, if this number happened to be, let me just remove this, if this number happened to be again as short size, minus 32,768 to plus 32,767, so 32,767 is a limit, no error. You can see that there is no error being shown over here. However, if I make this to 38, even a number more than that, I get an error message. Similar error message as we seen, incompatible data type. So I'm back to my original and this is what I have. So similarly with negative number as well. So I'm just using ones, minus till 38, it will work, no syntax error. Okay, but if I make to 39, I will get again the error. So this is how the system works here with a different data type. Similarly, if I want integer, I will use int, the number. Now this number is quite big, so we will not expose too much. You can always practice at home, try various numbers and see how bigger a number it can take. So if I say this 25, I'll just change this number to some big number. Okay, and I say compile, I'll get this value. So what I input, what I stored got printed. Same thing over here. Long. Now in long, as what we've understood here, that I must write or I should write L. So in case this number is big, I compile. Okay, it's still small, I compile. Now see, I have got integer number too large. Now if I apply here L, the same number will be accepted. That's how L is compulsory beyond a particular limit. Okay, so during your free time, you can always find out which number is the last number beyond which you need to use L. Otherwise, compulsorily you have to understand suffix L will be taken. Now, let us see one or two programs. So, you can refer to the sheet there. I have taken one program. I am taking a program, let's say, write a program to store wage rate as 75 per day and calculate and print total wage amount for 26 days. And the hint is given, wage is whatever the wage rate, that's 26, into the number, the wage rate is 75 and number of days is 26. So I have to multiply. So if I have to write a very simple program for this, what I'm going to do here is I'm going to open this. I'm going to say my days is 26 because that's what the question is given there. The question is 726 days and rate is 25. So I'm going to make it rate is 75 per day and then wage is days into rate. So computer will multiply that. Now that will be a new number. So I need a new memory address and then I print it. So when I compile this, computer will show me the amount, the salary amount, the wage amount. Now this number looks just a number. it doesn't signifies anything what is this number is all about. So what we need to learn here is to add a message. What does this 25 going to come? Because user cannot see the program, user can only see the output. So what you can do is you can provide a message. The message is alphabets, so it has to be written in quotes. So before wage, what does the wage signify? So I'm going to say your wage is equal to rupees, and I'm going to say dot here. I'll close the quotes. Now between them you have to apply a plus sign. Plus sign is to join the message and the variable value. So computer whatever is calculated, that's 1950, will be applying. So behind the message it will be joined. So if I compile this, it shows me no error, and when I run this program, I see at least on the screen the wage is equal to rupees 1950, which carries some message, some value. So this is how the programming is done. I hope you all have understood this. We will carry on from here, and in our next session you will have to practice all those programs on which the data items are given as integers, and in the next session we will dealing with the decimal data types. Thank you.